All right, we are going to take a look at section 11.4 next. And 11.4 is titled the binomial distribution. So the binomial distribution, what we're going to be looking at are problems where the probability of getting a success remains the same, and you're looking at multiple attempts. And so an example of that is to say that, hey, we're given a true-false test. Let's say that there are going to be 15 true-false questions. So we're hoping to get the answer correct. So the probability on one particular question, any one question, the probability of a success is 50%. So this probability, we're going to use, let me make sure you use the right letter here. We're going to be using the letter P for this. So P equals the probability of success, and that's as a decimal, not a percent. So in this case, when we're talking about a true-false test, the probability of choosing correctly is 50%. So as a decimal, that's 0.5, so or 0.5. That's the P. So if I said, hey, what's the probability that I guess right on one question? If I were giving one question, it'd be 50%. But if we say, hey, what's the probability that we get 7 questions correct? That's what we want to find out. So let's do that. So find the probability of answering, I'll say, the given number of questions correctly. So they'll say this. So we're doing example 1 here. So in case A, we said 7. So we want to find out the probability of getting 7 questions correctly. So we have. I want to remind you of this cheat sheet that you got last time for the calculator. Notice I'm over here in the right column for a binomial distribution. That's what we're looking. Now there are 2 subheadings here for not cumulative and for cumulative. We need to go ahead and address those. In this case, if I just ask you what's the probability of getting 7 correct, that is not cumulative. Cumulative were to be if I were to say, hey, what's the probability of getting less than 7 correct? So if I say less than 7 or 7 or fewer, maybe I should say that, then I could get 7 right, 6 right, 5, 4, 3, 2, 1, 0. All of those would be true, and I have to consider all of those cases. So that's when it's cumulative, when you are adding in all of the different unique scenarios. In this case, I'm asking just straightforward, one case, so it's not cumulative. And so what we're going to see, if you look on this sheet again, we decided this one's not cumulative, so we're going to hit second vars. It's a binomial PDF. You'll notice if I scroll down to the cumulative ones, they use here binomial CDF if it's cumulative, PDF if it's not, CDF if it is. It's not cumulative here. So we're going to go through those steps. So I've got a graphing calculator here. You'll need a graphing calculator also. Let me clear it out. Actually, I'll just reset the calculator. Okay, so I've got a reset calculator. I want to point out these buttons to you. So it says second, you know your second, that's the blue button. And then vars is this button right here, right below your arrows, V-A-R-S. So we're going to hit second vars, because up above it it says in blue distribution, so distribution. We're doing distributions here. So this is a binomial distribution. So I've chosen that. It brings up two different tabs. We want to be in the distribution tab. That's what we want to draw. But we're looking for a binomial distribution. So I'm going to have to scroll down. And it tells me on that sheet, on the cheat sheet, once again, if I come back over here, it tells me I'm looking for option A, capital A. A doesn't come until after all the numbers. So binomial PDF is what I'm looking for. So I'll scroll down. 6, 7, 8, 9. Then comes 0, and then A. Binomial PDF. There it is. Notice when we want the binomial CDF, the cumulative one, it's option B. But we're looking for not cumulative. So binomial PDF. How many trials? Well, how many questions? Well, there were 15 questions. So 15 trials. P is that probability of a success on one given trial. Well, that was 50%. Remember we said as a decimal? We already talked about that up here. X is how many successes are you trying to get? We want 7 successes. And then we go down to hit paste. Seems like a weird thing for them to put, but what they're going to do is they're going to take those numbers and plug it into that function for us. Now today, we're going to be asking you to write down what's typed in your calculator. And so I'm going to write that down before I write my answer. So this is what I'm going to want to see. So binom PDF, parentheses 15 for 15 trials, comma, 0.5, because there's 0.5 probability on any given trial, comma 7, because we're trying to get 7 successes. We hit enter, it'll give us our answer, and it's in decimal form, not as a percent. You can change it to a percent when we give our answer. Sometimes that's nice to see. So about 19.6% chance. So if we had a true-false, a 15-question true-false test, and I just randomly guess. I don't know any of them. I guessed on all of them. What's the probability that I get 7 right? And 7 right is less than 50%. You'd be failing the test. 7 right is 19.6%. Now, what we didn't figure out is what's the probability of getting 6 right, or 5, or 4, or 3, or 2, or 1. We didn't figure out any of those things. That's one specific thing. What's the probability? Let's do another one. Let's pick a bigger number this time. I'd like to get 10 right. Maybe I want to get more. I may well go 12 right. 12 right would be a B. It'd be an 80%. So we're going to choose all the same options. So second vars, I can scroll up. That may be faster to get to A. Binomial PDF, still 15. It saved all my numbers from before. 15.5. This time I wanted 12 right. Paste. Give it to me. 1.4%. So what I did, I need to write it down. Binom PDF 15, comma 0.5. This time I wanted 12 right. And I got, was it 1.4%? Not a very good chance of getting 12 of them correct. Hey, well, I want to know maybe, part C, what is the probability that I get 9 or fewer? Now 9 questions would be a 60%, would be a D minus. So we're saying D minus or less, failing or at best in 60%. What's the chance of this? So this is not just 9, this is saying it could be 9, 8, 7, 6, 5, 4, 3. So this is cumulative. So we are going to choose, when I go to my second vars, when I scroll, I'm not going to choose option A, I'm going to choose option B. Whoops, I went too far. Binomial CDF, because it's cumulative. Now I have to start over here. So I had 15 questions. Probability of getting one right is 50%. I'm trying to get 9, and it knows or fewer, so you don't have to worry about that part. It's assuming that. So hit paste. So this time as I copy this down, binom CDF, because it's cumulative, 15, comma 0.5, comma 9, and I hit enter, and it will tell me 84.9%. Make sure you understand what that means. That's not telling me I have an 84 or almost 85% chance of passing the test. It's saying I've got an 85% chance of getting 60% or worse. So I'm probably going to get 60%. Of course, I'm going to assume 50%. 50% is what I'm assuming. And so I'm probably going to get 60 or worse. So it's an 85%, almost 85% chance that I'm going to get 60% or worse if I guess on every single one of the questions. Now what happens if we make this a multiple choice test? Let's say there's A, B, C, D. So 6 multiple choice questions. I'm going to say in parentheses options A, B, C, D. Of course, some multiple choice have different numbers of options, but that's kind of a standard. So in this case, assuming one of them is correct, that's a 0.25%, or 0.25 is RP, that 25% chance of getting it right. So let's find the probability. Oops, got ahead of myself. Probability of answering the given number of questions correctly let's say, so we've got 6 questions. Let's say I want to answer 5 of them right. So this is not cumulative. So it's going to be a binom, a PDF. There are 6 questions, 0.25% chance of getting one right. We're trying to answer 5 of them correctly. So now to type that in the calculator, I go to that second vars, find binomial PDF, 6 questions, 0.25% chance. We're trying to get 5 of them right. Give it to me 0.4% chance. Not good. Let me try something real quick. What I want to know, because sometimes it's such a small, yeah, here, okay. I'm going to say 6%, or 6 questions, okay? If that was a 0.4%, this probably really isn't good to get all of them right. What's the likelihood that I'm going to guess them all right? So it's PDF, it's not cumulative. 6.25, I want all 6 of them right this time. Let's find out. So go to second vars, binomial PDF, 6.25 and 6. And notice it gives it to me in scientific notation. So what are we going to do as we write this down? We're going to convert it from scientific notation first of all. So 2, 4, maybe I'll write that. Put my pencil after the 2, like where it is right now. It's saying it's e to the negative 4, so I need to move my decimal 4 places to the left. So let's do that. 1, and we're in front of the 2. Now we got to fill in some zeros. 2, 3, 4. So we fill in zeros, so it's 0.00024 is what that would be. Now to change it to a decimal, I'm going to move it back 2 places. So if I move it back 2 places, I have 0.02% chance. I don't really want the answer in scientific notation, so that's how I would handle that situation. All right, let's try maybe a relevant sports question. So I don't know if you're an NBA fan. I'm not really, actually, but the Golden State Warriors and Utah Jazz are playing in a best-of-7 series. At the time of making this video, the series hasn't started. I don't know, it probably starts tonight on Monday, but it hasn't started yet. So it's a 7-game series, so the Warriors against the Jazz. I'm going to go ahead. I don't know what the likelihood is of the Warriors winning. I'm assuming they're going to win. I'm going to say that they have a 0.65 or a 65% chance of winning any given game. Okay, so we've got the Warriors have a 65% chance of winning. Maybe it's even higher than that. beating the Jazz. In a best-of-7 series. Now, because it's a best-of-7 series, that's a little bit different. We have to be careful as I do this figuring. Sorry, there's an announcement. It's not a guarantee that all 7 games will be played, which is a little bit challenging for us to figure out because that makes each of these questions a little bit unique. So here's what we're going to do. We're going to take out the best-of-7 series. We could adjust it, but this will make it a little bit easier for you. Well, actually, I don't know. Maybe not. Here's what we're going to do. I want to find the probability that the Warriors sweep. So best-of-7 series, someone has to win 4. So what is the probability that the Warriors win in 4? So win 4 out of 4. That's my question. So it's not cumulative, but we've only got 4 trials. We're going to try and win all 4 of them. Oops, I don't know why I'm writing this. So here's what we're going to be entering in the calculator. It's a binomial PDF because it's not cumulative. Playing 4 games, they have a 0.65% chance of winning a game, and we want them to win all 4. Let's see what the chances are of that. So, second VARs, binomial PDF, 4 games. We're giving them a 65% chance of winning. We want them to win 4. Pace, let's see what that is, 17.85% chance. We'll call it 17.9%. Almost 18% chance that they're going to sweep the series. Now we're just making up numbers, so I have no idea what that actually is. But let's say that's the case. Let's say they go all the way to 7. So they don't win it in 4, they don't win it in 5, they don't win it in 6, they win it in 6. Or they win in 7. So Warriors win 4 out of 7. So they're going to play all 7 games. They can't win more than that because that's not the way the series works. As soon as they get to 4, the series just stops. They've declared a winner. So we have to kind of modify the case here a little bit. So this is not cumulative again. They're playing 7 games this time, 0.65% chance of winning one of them. We're wondering, what's the probability that they win 4? If they go to 7, what's the probability Warriors win 4? Okay, here we go. So binomial, 7 trials. We get a 26.8% chance. So it's more likely, what this is saying is it's more likely that they're going to win in 7 games than it is in 4 games. It's not saying there's only a 26% chance that they're going to win the series. It's saying it's a 26% chance they're going to win the series in 7 games. We didn't look at 5 games or 6 games. We just looked at that one case. So that's kind of what a binomial distribution is. So pay attention if it's a PDF versus CDF, and then answer correctly. Good luck.